So welcome to the video lecture. So now we see about the testers on aggregates. So first and foremost we see about the abrasion test. The principle of Los Angeles abrasion test is to find the percentage wear due to relative rubbing action between the aggregate and the steel balls used as an abrasive charge. The Los Angeles machine consists of circular drum of internal diameter 700 mm and length 520 mm mounted on a horizontal axis, enabling it to be rotated. An abrasive charge consists of cast iron spherical balls of 48 mm diameters and weight 340 to 445 gram is placed in the cylinder along with aggregates. The number of abrasive spears varies according to the grading of the sample. The quantity of aggregate to be used depending upon the gradation and usually ranges from 5 to 10 kg. The cylinder is then locked and rotated at a speed of 30 to 33 rotation per minute for a total of 500 to 1000 revolution depending upon the gradation of the aggregates. After a specified revolution, the material is sieved through 1.7 mm sieve and past fraction is expressed as percentage total weight of the sample. This value is called as the Los Angeles abrasion value, and the maximum value of 40% is allowed for WBM base course in Indian condition, and for bituminous concrete a maximum value of 35 is specified. So here you can see the Los Angeles abrasion testing machine, and second picture we show the steel boards which has been used for the abrasive action. So next comes the impact test on aggregates. The aggregate impact test is carried out to evaluate the resistance to impact of aggregates. The aggregate passing through 12.5 mm sieve and retained on 10 mm sieve is filled in the cylindrical steel cup of internal diameter 10.2 mm and depth 5 cm, which is attached a metal base of impacting testing machine. The material is filled in 3 layers where each layer is stamped for 25 number of blows. Metal hammer of weight 13.5 to 14 kg is arranged to drop with free fall of 38 cm by vertical guides, and test specimen is subjected to 15 number of blows. The crushed aggregate is allowed to pass through 2.36 mm ISC. So the aggregate impact value is found by the formula, that is W1 by W2 into 100, and where the W1 which is the total weight of the sample and W2 is the percentage of aggregate which passing through the sieve. The aggregate to be used for wearing course, the impact value should not exceed 30%, and for the bituminous macadam the maximum permissible value is 35%, and for a water bound macadam base course the maximum permissible value defined by ARC is 40%. So here you can see the abrasion testing apparatus. Next comes the shape test, as the shape is very important for an aggregate. So the particle shape of an aggregate mass is determined by the percentage of flaky and elongated particles in it. So the aggregate with the flaky and or elongated are determinant to higher workability and stability of the mixes. The flakiness index is defined as a percentage by weight of aggregate particle whose least dimension is less than 0.6 times their mean size. So for determining the flakiness index of aggregate, it is consists of panel having accurately cut slots of different standard lengths and width. So you can see that in the picture itself. So the particle is elongated when its length is more than 1.8 of the mid size of the C fraction. The aggregate to be classified is separated into 7 C fraction from 63 to 6.3 mm, and each fraction is examined separately. So 6 labeled openings between the pairs of metal pins measures particle from each of the 6 sieves cuts below 50 mm. The mass of all the elongated particles as percent of the sample is elongated index, meets the BS, that is 812. So the elongation index of an aggregate is defined as the percentage by weight of particle whose greatest dimension, that is the length, is 1.8 times their mean dimension. This test is applicable to the aggregate larger than the 6.3 mm. So discard all aggregates retained on 50 mm BS test C and all the aggregate passing through 6.3 mm BS test C. Select the length gauge appropriate to the size fraction under the test and the gauge each particle separately by hand. The elongated particles are those whose great dimension prevents them from passing through the gauge. From the sum of the masses of the fraction as the trace, calculate the individual percentage retained on each of the various sieves. Discard any fraction whose mass is 5% or less of mass M1. Record the remaining as M2. The gauge each fraction as follows. Select the length of the gauge appropriate to the size fraction under the test and gauge each particle separately by hand. The elongated particles are those whose greatest dimension prevents them passing through the gauge. Combine all the weights, all elongated particles M3. So the elongation index we can calculate by the formula M3 by M2 into 100. So this shows the various apparatus which being used. So the next test is the water absorption test. So the water absorption test is the difference between the apparent and the bulk specific gravities or water permeability voids of the aggregate. We can measure the volume of such voids by the weighing the aggregate dry and saturated surface dry condition, which are permeable voids filled with water. The difference of the above two is MW. MW is the weight of dry aggregates minus weight of the aggregate saturated surface. That is dry condition. Water absorption is equal to MW by MD into 100. The water absorption values ranges from 0.1 to 2% for aggregates normally used in road surfacing.